In this video, we take a look at how to use pre-existing and user-devised subprograms. So for the purpose of your GCSE exam, you need to understand the difference between pre-existing subprograms and user-devised subprograms. So you've been using pre-existing or built-in subprograms or libraries ever since you first started to program. A real straightforward one is print. You simply use the word print, open the brackets, and then supply what you want to be printed to the screen, in this case the text string hello. All the code that actually makes that happen appear on the screen is hidden away from you. It's in a pre-existing, pre-written subroutine. Likewise, there's one called str, which you know casts or converts the contents of a data type to a string. Again, this is a built-in or pre-existing subroutine. You're also able to write your own. You write your own subprogram by starting with the word def, followed by the name you want to give it. You then supply in brackets either 0 or more parameters. So in the first example, we've defined a subprogram called output_throw. It takes in no parameters, but will run the code. The second one is called order_dice. It takes in 2 parameters, D1 and D2, and again the code is then indented that you write inside. You can write 2 different types of user-devised subprograms. You can write a procedure which simply carries out a task and just execute it, and this provides structure to your code and allows for code reuse. Or you can write a function, which is very similar. It carries out a task, but it also returns a value. And again, it's designed to provide structure to your code and allowed for code reuse. So in order to go through this and not do it in an abstract way, we're going to use this example of a program on the left, which is a simple program for playing a dice game. Now in this program, the code actually starts at the bottom of the code listing here. You can see one of the first lines of program code is a call to a subprogram, a block of code. So we hit the line output throw, and the program jumps and finds the block of code or the subprogram with the heading output throw. Now this code example is being shown to you in Python, but at the end of the video we'll show you the syntax which will be used in the exams. You can see that when we get to the end of this subproblem here, we hit a return value, and it returns the value of roll to the part of the program that called it. Now this makes this subprogram output throw a function, because remember functions return a value whereas procedures do not. You'll also notice that inside the function output throw there's actually another function call to a subprogram roll a dice, and you can see that roll a dice returns a random number from 1 to 6. Now this wasn't really necessary. We didn't really need to put a single line of code, random number 1 to 6, inside a separate function, but we've done it here to show you that there's nothing wrong with calling one subprogram from inside another. And again, because the subprogram returns a value, it's again an example of another function and not a procedure. You can also see that output throw calls another subprogram, order dice. And you can see that once order dice is executed an if statement, it returns the largest dice first. And again, because it returns a value, it indeed makes order dice an example of another function. The advantages of using subprograms is a program becomes easier to write and it becomes easier to debug. We are effectively creating reusable program components with their own bespoke name. We could then gather these functions together into a library for easy use across multiple programs. Indeed, we're using an example of a library in this program, and you have done this already in programming without realizing. So we have a library called random, which we import into our program at the beginning. This imports the entire random library of functions into our program, so we can then use those functions within our program. The program is also much easier to test if we block and chunk our program down like this into subprograms, because we can test each procedure or function individually on its own, and when we know it works, we can plug it into a larger overall program. Here we can see how subprograms are called from inside flowcharts. There's a specific symbol used in flowcharts which tells you that you need to jump off and start executing another flowchart. And when you reach the end of that flowchart, you'd return from the one that called it and carried on. So this is the flowchart for the previous program we showed you in Python. Pause the video for a second and just work through it slowly so you can see how you jump back and forwards between the different flowcharts as they're being called. So let's just recap then. Larger programs are developed as a set of subprograms called subroutines. Structuring code into subprograms makes the code easier to read and debug. Now there are two types of subprograms. There are functions which return values and create reusable program components, and there are procedures that simply create a modular structure to a program, break it down and make it easier to read, but they don't return values. Each subprogram can be easily tested, and subprograms can be saved into libraries and then imported and reused in other programs. So we've just summarised on the screen for you the 4 different ways that you're expected to know to write user-devised subprograms in the exam. And this is from the PLS document. We've got a procedure with no parameters and a procedure with parameters, and then a function with no parameters and a function with parameters. They're all essentially very similar. The difference obviously with the function is you must have a return line. So that's the theory content of the video covered. We're just going to spend a little bit of time talking about the programming language subset. If you've heard this before, you can skip the rest of this video. Otherwise, it's definitely worth a quick watch. So the exam board at EDEXCEL have released a document that they call the programming language subset, which you can see here on the right. This document specifies which parts of Python 3 are required in order that the assessment can be undertaken with confidence. Students familiar with everything in this document will be able to access all parts of the Paper 2 on-screen assessment. The exam board will not go beyond the scope of this document when setting you any questions in the Paper 2 exam. Any students who do successfully use more complex methods, which are not included in the document, will still, however, be awarded marks. Further to this, you will see here from the front of the exam paper that you are actually going to be supplied with a printed and an electronic copy of the PLS during your Paper 2 exam. Well, if this document outlines everything you need to know in order to program in Python during the exam, and you can be guaranteed that you can answer all the questions using all the techniques in this document for full marks, then you might as well get used to using it now. Ask for a copy from your teacher and have it as a reference guide at all times throughout your GCSE course. It will be invaluable.